Hello everyone, welcome to the next part of the alien egg videos. First of all, thank you for watching my channel. I see a little bit of growth in the channel. Thank you for following and thank you for everything. Please like and subscribe my videos. You can support me a lot by doing that. I really like doing this and making these videos. So let's continue now. For doing the part that the tendrils that are coming from the ground, and it seems that they are holding this egg mm, in place, we need some floor. So for the floor, it's very simple. We are going to do a grid, and this grid is going to be like this, but we need a lot more points on it. So I'm going to use a remesh on this grid, and this remesh is going to be like, let's see, yeah, it's okay, maybe a little bit more thing. Oh, this is too much. Sorry, I needed to do this. Okay, that was a lot more resolution. This is okay. Now we need to have normals on it, and I'm gonna tell you why we need normals. And this is it. Out, floor, or let's see, ground. Because maybe later we want to do some noises and other stuff on this. Now, I'm going to do import on this in ground, and let first of all put it here, and now we are going to put this here, and the egg we are going to have it here. Now we are going to select some part of the ground based on the grid. So imagine we have to know which part of the ground is going to be selected, or which part of the ground is going to be affected by this. So, I'm going to show you what I mean. Maybe I cannot. Okay. We can do two things. We can use the scatter points that we used here in here for this, or we can do new ones. So let's do some new ones first, and then if we want, we can reuse some of that again, some of the already we have already some scatter points, but we are going to make new ones. Now this is okay, and this we can do something like this. I want some more points. Okay, now there is a node called distance from geometry. So we are going to get the ground on the other side, and we're going to select some of these points based on how far they are from the ground. So if this is distance, but I want to use distance in geometry and points, and make a mask. Hopefully it's okay. Now the mask is okay. You are going to visualize the mask. Now you see we have something like this, and we can make this radius like this and bring them up like this, and we are going to select these points based on the distance, basically. So we can put it like constant, and yeah, I just want mask to be 0 or 1. That's enough. I don't want any gradients on the mask, so this is good. Now I'm going to delete based on the mask. So another blast. If you can remember, like the previous video, we are going to make at mask equals 0. By the way, equal in the expression, you have to put 2 equal sign. It's not an assignment. We are going to do some tutorials on Vex. I'm going to explain all of that. Don't worry about it. Now I don't need the mask anymore. Or yeah, I don't want to. So let's see. We have the normals. Yes, we have the normals. And we need to do some okay. Now we are going to shoot some rays based on the normals onto the ground like this. So we are going to say ray, and this ray is going to be this. These are points, and this is our ground. Now, based on normal, some rays are hitting the ground, as you can see. Okay, now let's turn off this, and we are going to have them in a group called ray hit group. The points that are hitting the ground will be in the group, and the point that are not hitting the ground, like this one in this tree, are not in the group. And then we are going to delete all of them based on that group. So this is non-selected, and here we go. We have something like this. Now we are going to make some lines between these two groups. For that, we need to be able to identify each one. And like we didn't do this here, but if you remember the bridge asset, we did it there, and we are going to put enumerate and call this ID or index. You can call it both, but I named them ID. This is one way to do it. You can see there's going to be and in the points, we want to enumerate the points, and there will be an ID attribute which is exactly the number of point number. It's going to be the point number. If you don't want to use enumerate, you can use wrangle, and in wrangle you can do I at ID. That means make an attribute with the type of integer and assign it the point number, which is pt num. And if you look now, it is exactly as the enumerate. You can use both. There is no difference here. If you want to feel more professional, I guess, you can use Vex in this situation. Now, we have two sets of points which are connected to each other with the ID number. If you see this, there is a point. You should have points that have the ID number. And yeah, and we are going to do add, and this add is going to be, we're going to go to polygon by group by attribute, and the attribute name is ID. So it says whenever you find a point that is the same ID, connect them to each other. I hope it makes sense. And what we are going to do is we are going to see some points that are not connected. You see that? These points are the points that are not getting hit by, you see, getting hit. They are these points. And we want to delete them. The best way to find them and delete them in here is to see if they are having a neighbor, and if they don't have anyone near them, or if they're not connected to another point, then we are going to delete them. And we are going to do that with wrangle. It's a 2-line very simple expression. So we are going to say int number neighbor count, and there is a function called neighbor count, as you can see here, neighbor count, and we want to see count the neighbor 0 and within pt number, which these points we want to count each neighbor of the points. And if we export this in attribute, we can see some of them are 1 and some of them are 0. The 0 ones are the one that doesn't have any neighbor. That means they are not connected to any point and they are alone. And we are going to delete them, because if you're alone, then you have to go. I don't know. You are. I don't know. Okay. Now we are going to do int and see neighbor count. Everything is good. And now we are going to say if nc, that means the variable that we are having up there is equals to 0, then we are going to say remove. Something weird is going on here. I don't know why. Let me bring another note here. I didn't know why, but the colors on the notes were gone somehow. If the nc is equals to 0, then remove point, point. Like my keyboard is typing some of the things twice. At pt num, and also with putting 1 at the end is, that means also delete the primitive. And you see the single one are gone. Okay, delete unconnected points. Okay, now these are our roots. Now I'm going to say out roots. Okay, and now we are going to resample all of them. Resample. Okay, and when we resample them, we have some useless attribute on them. So we are going to delete all of the attributes. Now here's all of the attributes are gone. Okay. And now we are going to connect all of them together with, like here, we are going to use the connect adjacent pieces and make a network. So this network, I don't really like it. I really don't like it with this. I'm gonna make this a little bit bigger and more connections. Yeah, it's good, kind of good. Let's see what happens. Let's resample again, and we're going to resample everything again. And this time I'm going to use, let it be every single, we need a lot of points. Okay. And then you know the procedure, we need to fuse them all together. And now we are going to use some, we're going to use an attribute blur. Attribute blur. By the way, I'm going to do this like I did it, and I found out why I did some of this. I don't want you to just click at the nodes. I want to understand why I do some of what I do. So unpin border, when I unpin this, you see everything is getting smooth, and I don't want that. I want this parts that are close to ground stick to ground, and I want these ones to get smoother and get like this. So we are going to use the distance from geometry again, but this time we are going to use the egg. So we are going to say distance from geometry. This one's based on the distance between these two, and we are going to make it, I don't know what happened. Now I'm going to, this is going to take a long time, so let's do something like this. I'm going to clip this. I'm going to clip this not like this, but like this. And I'm going to make it like this much, and this much. Okay, let's see what is going to happen here now that we have less numbers. So distance from surface, maybe. Oh, okay. Okay, we did that. Okay. Now everything is fine. And primitives, and we don't need distance, we need mask. And we want to have the mask like this. And I'm going to make it so that these ones, so we don't need this, we want to use this, and weight attribute is going to be mask. And you can see when I smooth everything, you see these are where they're getting small from here. Now let's see what we can do with this. I think we have to make it like this, maybe, or something like this. Bring it down, and also bring this down, because the points that are connected to the egg, I don't want them to be affected by this move. Maybe a little bit. Let's see what's going on. Okay. And now we are going to do another resample and another fuse. Let's see what's going on. Now, you see, these are two uniform. Now that we are here, I see that these are a lot, they're not like webs. So I'm going to do something else here. And what I'm going to do is up here, when we are enumerating the points, before we project them basically onto the egg, I'm going to select some of them and make some of them project and make some of them not project, as because I want uh, more of these points on the ground. So this is one way. There is another way. I'm gonna tell you that. So there is a node called random selection. Now I'm going to put this random selection here, and I'm going to tell it to, by count, maybe 15. I want to select, no change color, and delete non-selected. Okay. Now we are having some of these here, and yeah, this is just like that. Resample and use it. So you see this, and now I want to have something like this. Okay, now I want to add some points on the ground, but for doing that I need to have scatter points around these points. For doing that, I'm going to add a circle, and polygon circle, and I'm going to copy that circle onto these points. So this is my circle, this is my points, yeah. And for that, I'm going to these have normals. Have to delete the normals on them because it's going to be a problem. Yeah, okay. And I'm going to put this on ZX. Now we have circles that are around this. See that? Now I'm going to say put it at the 0.5 and put attribute randomize. In this attribute randomize, I'm going to say p scale, and on the p scale, it's going to be from 0.5 to 1, and I'm going to make them a little bit, or we can do it here, maybe put 1 here and do it at this level, so everything is in the same place. Okay, and then I'm going to scatter points on this. Scatter y. This is it's going to be like this, but I don't want relax iteration, and I want it like this. Or you can do it here and have them copy with your every circle. But I like it right here. You can, of course, test that or add something like that. And we have 1,000 extra points here. Now we can do, what we can do is we have this here, and now add we can add it together, these two. Now we can add all of this together and put the connect adjacent pieces here. So you see that there is a lot more, there's yeah, there are a lot organic. And let's see, maybe we don't want to do that, or maybe we want, or add some connections. Okay, I don't want them to be okay. Resample, fuse, and distance like before. And now we are going to see what is going on. Now let's see.